Cool. Hey guys. So essentially, this is blockchain vibe coding. So we're going to look at how you can learn about blockchains, but also how you can vibe code solutions with blockchain. Vikas is the master of that actually. I'm going to be joined by someone named Doug. Doug Bailey, and he'll be helping me out on some of the other lessons that we have. But tonight I'll be leading with what we are doing. I'm just going to share my screen to show you where you can find a bit more information. And then I'm also going to do this very, what's the word that I'm looking for? Impromptu. So I'm not going to really use a script. Wait, I kind of got lost there. So essentially, if you go here, you'll see that they are supposed to be two, but there's only one. Let's see now. If we go here, it should be part of a playlist. So here's, sorry guys. So here's the one video that basically explains introduction to blockchain. It's pretty cool. It was made with Notebook LLM, which is a Google product and solution. There is a second video, and I'm going to find it for you in a second. So that one deals with the basics of blockchain. And then the second one, nope. Sorry, I clicked too fast there, I think. Playlist. So we've got that video, and then we've got these two videos. So as the weeks go on, I'll load more videos here, and you're more than welcome to watch them. I'll paste a link to the channel and the playlist in the chat so you guys can check it out. Sorry, I'm just letting someone in. Excuse me for the delay. And then essentially, like what we've done is we've designed the course with some supplementary material, some more supplementary material as well. So we have, if I can share this tab instead, we've got a blockchain vibe coding study manual, which actually comes after the other manual that we have, and I'll share that with you as well. I just need to let someone in who's already in. Oh, there we go. Sorry, guys. The technology is not cooperating to admit people. Okay, cool. So essentially, we have the module 1, Introduction to Blockchain. This is like the a comprehensive guide. So the guide goes through a lot of the things that I'd like you to learn on your own. So essentially, you've got distributed ledgers, decentralized, immutable, transparent. But I want to go off the cuff and essentially explore other things that led to the technology that we have. Lastly, I want to share this with you guys. So this is where you can find the course as well. So if you're looking for something that has a bit more in depth, you'll be able to go here. It's on our website. You basically have the lesson, which is the same as the PDF, but obviously if you want to study offline, that's why we created the PDF. We have a video. We have the audio, which are both uploaded to YouTube. We have a study guide for you guys. Then there's also a quiz which you can take, and you can take the quiz as many times as you want. There's also flashcards, and then there's a mind map as well. For most of these, there will be slides. For this one, there isn't any slides, unfortunately. And then you can also take some notes if you'd want to. Just bear with me. I need to let someone else in. Sorry, guys. Cool. So that's essentially the where you can find all the resources and all the resources that we've created. Does anyone have any questions so far?
Nope.
Nope. Okay, cool. So essentially, I'd like to start off by just looking at an alternative version of the notes here, because wait, let me share this tab. Sorry. Nope, it's not this one. It is this one. Um, let's close that. Cool. So essentially what we have is an introduction to blockchain. What is blockchain? How does it work? It's pretty, it sums it up pretty nicely. And essentially what I want to look at is other things. So I want to kind of, so basically you have like timestamps and how your computer works, but I'm going to explore different things because I think I want to know other stuff from you guys. So have you guys ever looked at torrents? Do you guys know how torrents work? Anyone? Okay.
Um, that that
Sorry.
peer-to-peer file syncing, file downloading.
Yeah. So
Basically.
essentially, it's a lot of illegal things happen with downloading. So this is if you remember from the 2000s and the 90s, I think. No, I don't know. Maybe it was the 2000s. With illegal movies and pirated content. So that's where this kind of comes in, because with the torrent, you can basically download a shared file. The shared file is on everyone else's computer. So if you look at a legal example of this, you can look at LibreOffice. And with LibreOffice, you can actually download, you can download now. And if you download, does this download the whole thing? Where is the torrent? I don't know, it's there somewhere.
Another
There
example
we go.
is actually Windows updates. I think it works on the same idea. And if you have Steam, we download games. I think that also works on a similar method for downloading the game.
Yeah. Okay, cool. So essentially what happens if you click this, it'll open up a link that'll then activate this program, BitTorrent, for example, if you have that installed, or you can get uTorrent. So uTorrent is also, all of this is actually owned by Jason Sun. So Jason Sun also is the owner of Tron. Has anyone heard of Tron? It's a cryptocurrency. Okay, cool. So yeah, so he bought all of this. And if I'm not mistaken, BitTorrent is also has a coin. So BitTorrent coin. Yeah, there you go. So BitTorrent has a coin. So if you look at that, you'll actually see that here's CoinGecko. You can find some useful information about cryptocurrency. They have a coin. It's worth 6 cents per coin, and it has crashed terrifically. Not actually, because it's been at like 6 cents for a long while. So essentially, like, that's how you can get a file that's distributed. But that's the same way that blockchain works. It's basically housed on all these different computers. In torrents, it's called peers. In blockchain, it's called nodes, but they all basically mean the same thing. Someone is holding part or the whole file on their system somewhere. If someone wants to access it, they'll be able to go forth and find the information for that file. And then I'd like to show you another interesting example. If I can, sorry, give me a second. I want to close this. Do you guys actually understand how to use SSH keys by any chance? Has anyone worked with SSH keys yet? Okay, cool. So let's see if I can just find this thing, this one. Okay, so this is W, oh, is it loaded yet? Can you guys see my screen? Oh, you can see my screen.
Yep.
Okay, so this is WSL. So you can install it on top of Linux. Okay, I'm going to close that, and I'm going to open a normal one first, so I can show you guys some interesting things, because this is kind of the precursor to some of the programming that you'll be doing. And I think you guys need to figure out what's going on there. So window, share. Okay, so essentially you have PowerShell or the terminal in Windows. If you hit the Windows button, you can type in CMD, and then this will basically pop up. It's called a command prompt. And then once you're in the command prompt, I install this program off of Windows Play Store. So I went into the Windows store, and I basically looked up Ubuntu. So that's Ubuntu 24.4. I downloaded it and I installed it. And now it's using this program called WSL. So when I open it opens Ubuntu on my server. Ubuntu is a Linux-based solution, or Linux-based operating system. And Linux is just a different sort of operating system to Windows. It was yeah, it's just free. It's open to use. Anyone can use it. You've got the GNU. What is the GNU thing called? Um, Sorry, I need to figure this out. But yeah, it's part of GNU, which is another sort of licensing standard, and they do a host of other things. So essentially what you can do with this is you can see what files are here. So if you type in CD, which means change directory, you can, okay, yeah, if you press tab, it'll show you the files that are available and where you can go to. So if you type ls, all list inode. So the A is for all, the L is for list, the I is for inode. And so basically what you will see, if you guys can see my mouse, is here are the permissions that you have. So whether it's read, write, execute. The first three are for the user, and then if I'm not mistaken, it's for the group. Oh, sorry, it's for root. Then the root is the most powerful version of this. So anyone that's you need to be an administrator or special permissions. Then it's the group, and then it's the user. And then over here, what you see is the actual directories or files. And then you have a timestamp. You've got the file size, the dates, the user that actually created these. So if you do ls, it'll just show you the basic version of this. So if you want to make a directory, you can type in mkdir, and then which is make, just with, and then dir is directory. So you just mkdir, and then I can just make something called test. So this will make a directory called test. If I go to cd and I type in test, I can then go into cd test. The reason why I'm doing this in test is so that I can delete this afterwards, and it doesn't basically block up everything that I have. SSH keys, keygen. So basically with this, what you're going to do is you're going to be creating ssh-keygen on Linux. There are two standards that you can use, the ED 25519, or you can use RSA. And when you basically do this, you basically are creating a secure key. So think of this as your public and your private key. So I copied and pasted that because I just did. And so basically, this is what it's SSH keygen. There's your standard, and here's your email. So your email is very important as well because it plays a role in the unlocking. So what you can do here is you can create a password to unlock and get you further if you don't have to. Oh yeah, I just hit enter. Let's see if it works. There we go. So now I've generated two files. So if you go ls again, where did it go? Oh no, I didn't name it. Enter a file name. So I'm just gonna call this root, and let's just say like server, and enter. So now we've got a server version, and you got a private key and you got a public key. The one that's called .pub is your public key. So in blockchain or cryptocurrency, you have a private key and you have a public key. I would like anyone other than Vickers to try and answer what's the difference between a private key and a public key, or like in terms of blockchain, you have something called an address, which is where your money is going to. And then you have the private key that allows you to transact on the network. So looking at the public key, private key, would anyone like to take a guess at which one is the public key and which one is the private key? I'm just going to ask someone then. Pooty, what do you think do you think the address is the public key or the private key? Is it the key that everyone can see to send to do something with?
Pardon?
Okay, so you've got a public key and a private key. Now in blockchain, do you think the address, the address of where the money is going to, is that public to everyone or is it private? Do you only know it?
I think public.
There we go. Yeah, Ruth, it's also public. So that's the public key. So that's the key that everyone can see. So now if I go to what do I do now? So you can use I'm just going to use cat because cat root server, and we go .pub. This is your public key. This is what you paste on the server. That's the key that basically will unlock this other one. So if we then type cat root, then this is your private key. So this is the key that you keep to yourself. You never share with anyone, similar to how you would keep your seed phrase. So in cryptocurrency, you have a seed phrase, or you have an actual key that is your can unlock similar to this. So this is using the ED 25519 256. So 256 is how strong it is. And in Bitcoin, for example, it's SHA-256. So SHA is the algorithm and 256 is the key strength. One of the things about SHA-256 is apparently it is unbreakable by quantum computing. That is yet to be proven. I've heard some interesting rumors about it being broken. There are a lot of people spending a ridiculous amount of money. There's this guy called Charlie Shrem. Is it Shen or Shrem? Yeah, it's this guy, Shrem. So essentially, am I sharing? No, I'm not sharing the right video. Hold on one second. I need to cancel this. And then I need to share something else with you guys. Here you go. So there's this guy, Charlie Shem, and he's basically spending an inordinate amount of money. Well, not his money. He's getting other investors to do it, and he thinks that there's a high probability of it being cracked. If it's cracked, who knows what it happens? But obviously they want to go after Satoshi's Bitcoin, and that would be 1 million. Is that 1 million, guys? Nope, 1 million. Yeah, that's 1 million BTC in USD, and that would be worth I don't know, this amount of money, which is pretty ridiculous. So that is 500,000, 76 billion dollars at the current price. If you had to use computers to do it, if you want to actually play around with that, you can do that with IBM quantum computing. So these guys will give you 10 minutes of quantum computing. I know there's someone in here that can write it. Is it in Python, if I'm not mistaken? Who can actually write it. You can access it. They give you 10 minutes a month to write it and run it. So if you want to take a shot at $76 billion, you're more than welcome to try and crack Bitcoin. So essentially, that's the key side. Does anyone have any questions about like how these files are, how the blockchain is basically distributed on different nodes, or anything to do with like private keys or public keys?
Is the seed phrase always 12 words?
It can be 24 as well.
So it's either
Um,
12 or 24.
Yeah.
So
So it
is it based
depends.
on yeah?
Sorry.
Is it based on the wallet?
It depends on the wallet. It depends on what you want to do. Some wallets will basically ask for 12, and it also depends on how you want to set it up. So if you want to, essentially, it's a bit of both, because essentially your 12, once you have a seed phrase, it's pretty much transferable across multiple chains. Is there any? Do you want to know a bit more about that?
No, that's good. That's good.
Okay, cool. So basically, it's also another thing to consider is it's the security and level of security that you have. So obviously, if you're looking at 12 words, it is 128 bits of security. Where if you look at 24 words, it's 256, if I'm not mistaken. So basically, the 12 and 24 just give you different levels of security based on the length. Cool. And then, so I want to share this with you guys now. So essentially, like, there's a whole bunch of stuff about prehistory and how they came up with the encryption, who developed various things, the birth of Bitcoin, the expansion of blockchain. So I'm not sure who you were there yesterday when we looked at Ethereum and how it was created and how it did new things with money. And how we programmed on top of it. Are there any questions about Ethereum or programming smart contracts?
Not yet.
Not yet. Okay, cool. So yeah, so essentially, the architecture of a block is basically we have transactional data, like the who, what, when, where. So when we looked at Alice, we kind of saw what was kind of happening, like who was the file owner. So that would be like, where did it get sent from? Who did it get sent to? At what time? The timestamp, yes, is what time. The cryptographic hash. So how is it encrypted? So obviously with blockchain, each block is mined, and the way that a block is mined is you basically take all the transactions, you put them together. So if you think of a shop and how you would have numerous transactions being compiled together in a shop, and at the end of the day, they close up for the shop, and they know like this is the transactions that take place. So you have all of these transactions in one block or one day, in the shop example, and what they have to do now is they have to solve for this block, and a hash is basically created, and with that, and essentially in Bitcoin's case, it's SHA-256. There are a lot of other encryption algorithms, and then you use both the previous hash and the next hash in a blockchain. This is what makes it a chain of blocks. Is the previous hash has to make sense from the next hash, because if someone has to try and break the chain, what they would do is insert something where the previous hash doesn't work. Because if you watch the supplementary videos, you'll basically see that when you have a block that's mined on top of a block. If you wanted to pretend that a block was real when it wasn't real, you would subsequently have to remine every single block when you did your fake transaction, all the way up until the current point, to cement that transaction in. And when you look at cryptocurrencies, you often have to have 6 transactions before they release the funds to you. So let's say you wanted to do a Doge transaction on a cryptocurrency exchange, and someone sent that money to your wallet, and then you wanted to send it to someone else. It's not instantaneously available. With Doge, some of them want 40 transactions before you can then send that money. In Doge, it's 1 minute. It's 1 minute per block. In Bitcoin, it's 10 minutes per block. In Stellar, it's 3 to 5 seconds. Ethereum, it's 12 seconds. So it all depends on the different type of blocks that you have. But obviously, the more blocks that you have per minute, the faster you can do it, and the slower the network, the less blocks that they're mining. Sorry, guys. And then you basically have proof of work, which is where you're using a mining machine. So this is where you use electricity to basically validate the concept. So you're spending electricity to ensure that the network is secure. With proof of stake, what you're doing is you locking up your money. It's like taking your money and putting it in a bank account and then earning interest. And that interest comes in the form of fees. With Ethereum, for example, that's gas. But now when you are a node, you basically have the ability to have say in the network. So you can vote on certain proposals. So what you could have in Bitcoin is a BIP, or it's basically, and miners and nodes can vote on these changes. And if someone doesn't like a change, then they can fork the cryptocurrency. And a fork is basically an event in time where people say, I don't like this, I want to change. A very good example of this is Ethereum and Ethereum Classic. So there was a hack of, so what is it called now? DAO Ethereum hack. So this happened in 2016. And essentially what happened was they lost $150 million because there was a hack. And you had Ethereum Classic, which said, the people in Ethereum Classic said, no, you can never change. Code is law. We're going to start our own blockchain because we don't think that we should turn back time to remove the blocks of the bad transaction. Unfortunately, they lost that war, and Ethereum Classic is not worth very much at this stage. And then you have Ethereum, which continued on. Similar to how you have Bitcoin and Bitcoin Cash, they basically fork. So it's the same code base up until a point in time. After that point in time, they're basically formulating their own hashes. But anyone that had Ethereum basically gets now Ethereum Classic as well if they were holding in their wallets, similar to Bitcoin and Bitcoin Cash. Do you guys understand what a fork is? Cool. Thanks, Ruth. And then essentially you have nodes and miners. So a node manages a complete copy of the code. Light nodes only download basically the last little bit. So they basically don't see the entire blockchain. And then a miner like processes the transactions in a proof of work system. So you have public keys, private keys. We've already discussed that. Cold storage is storage that can't be accessed. And so essentially it's locked off, it's not online, whereas a hot wallet is online and is available. Let's see. So the evolution, basically you have Web 1.0, where it was just giving someone information. Like, here's a web page, only read this. 2.0, you can basically sign in and you can do something with the website, like an app, like Facebook, Instagram. That's Web 2.0. Web 3.0, now you can execute on these things, like essentially spend money. That's the and decentralization, meaning it's accessible from anywhere. Is there a question or okay, so I got asked a question. Based on the wallet to crack, it should be brute force. Okay. Oh, so I think you were talking about the component around using a supercomputer to crack Bitcoin. So you have to figure it out. Like I think it's going to be an inordinate challenge, and you can see how you want to brute force it. But I don't think you'd be able to brute force it in 10 minutes. You'd need to create a very sophisticated program that can actually explore it or play around with it. But I'm sure you're going to have a lot of fun. Actually, like looking at SHA-256, how to break it, how to reverse engineer it. You can look into to Web 4, but this basically is now we can give Web 3 to an AI to transact for us. I'm going to leave you to have fun with these questions and essay stuff. And here's a glossary for you guys to explore. So essentially, there's a video around the stuff that we covered here. And then there is the audio that focuses on these concepts, like beginner blockchain. So essentially, you've got distributed, decentralized, immutable, and transparent. And those are really like some of the major buzzwords around blockchain. So distributed means copies exist on thousands of computers worldwide, similar to torrents. Decentralized, no single authority controls it, similar to a torrent. As long as you have access to the link, anyone can start downloading it. Just remember, anyone can see anyone else that's downloading off the torrent network. So immutable basically means that once data is written, it cannot be changed or deleted. And that's what makes blockchain so secure. Also, what kind of makes things very problematic, because remember we talked about forks, Ethereum rolling back, which kind of means that it's not immutable. You know what I mean? The technology can be changed. It can be manipulated by certain people. In many cases, people can even argue that all blockchains are currently centralized because all the developers that hold the keys or access to the Git repositories, it's all a centralized system. So if you look at the blockchain, the Bitcoin core developer team, it's still a central group of people that it's a central point of failure, basically. Same with Ethereum. You have central individuals, the coders. This is why pseudonymous or anonymous projects could be better to invest in, could be better to learn about the technology, but at the same time, also very risky, because if you look at some projects, when you have when no one knows about who the developers are, they can often run away with your money, or they can program in faulty logic. So there's a lot of risks with knowing who someone is and not knowing who someone is. Transparent means that anyone can view a complete history of the blockchain. This is also pretty dangerous, because that means that anyone can see what everyone else is spending their money on. So whenever someone does a transaction in on the blockchain, you can see it, which actually makes it way more transparent than the current financial system that we have, which is, yeah, interesting. And then you have a ledger, which is basically a book. It's a financial accounting term, but in blockchain, basically it means just the record of all of the transactions kept by one single account. So essentially, I would love you guys to go through this stuff about what is the double spend problem and how you can't do it. That also lends to that component I was talking about in terms of how blockchain, how you break blocks. Because if you're spending twice, how do you spend twice? So I think you guys should read it. You're going to have a blast with that. And then this is a brief history of blockchain, Satoshi Nakamoto's white paper. The first blockchain essentially was Bitcoin, Ethereum, and programmable blockchain. So basically now you could do something with this blockchain. And then it goes, like, NFTs are very interesting because it's a non-fungible token, which means you can create something with that has value. So whether that's a piece of art, or whether you want to give someone a concert ticket, that's a digital version of something, and they can only enter with this electronic ticket. There's a whole bunch of interesting things happening around music and NFTs, and a lot of industries have really been affected by NFTs. DeFi is decentralized finance. CBDCs is central bank digital currencies. So a lot has been done around this. Nothing has been implemented where we're actually using a blockchain to do anything on the blocks. So we've covered this and chains, the networks, types of blockchains. So you've got a public blockchain, which is publicly available to everyone. And then you've got a private blockchain, which is Hyperledger Fabric. That's also, you can view it on, IBM has a version of this, but it's done by the Linux Foundation. So it is accessible to everyone, but the Hyperledger Fabric version has commercial support. So if you want to build a commercial project, you could use this. And then you've got a consortium of federated blockchain. So R3, has anyone heard about R3? Just curious. So essentially R3 was, ABSA was involved in R3 in South Africa. And it was a whole group of banks who basically wanted to do stuff on the blockchain. It didn't end so well, unfortunately. So we haven't really seen what's going on. But right now, ABSA is doing things with Ripple, for example. So obviously the relationship is continuing. So what can blockchain do? Real world applications. It can be in finance, supply chain, healthcare, boating, so patient records, art, in NFTs, royalty tracking, real estate. Real estate also has this thing called RWAs, real world assets. And then identity, gaming, and here's some key terms and glossaries. And then common misconception is that blockchain equals Bitcoin. Unfortunately, Bitcoin has a name where Bitcoin is the money and Bitcoin is the technology. So yeah, but a good example is like saying the internet is equal to email. They're kind of fairly different. Bitcoin is anonymous, not true. If you know who owns the wallet, you can figure out every single transaction that they're doing on the network. Blockchain is unhackable. So while the protocols are secure, everything can get hacked. I found this guy who actually figured out how to reverse engineer, basically break into hardware wallets. And basically what he does is he causes it to glitch, and then he basically gets the seed phrase out of the hardware wallets. But he's a very talented electrical engineer, and I will share some videos or links to it. Well, you have to have access to the device, Precious. So, and yes, you have to, like, trust me, guys, it's not as easy as it sounds. Like, you basically have to have access to the device. You have to have the technology. It's really ridiculously expensive. It's not something that's easily replicatable. It's fairly complicated. And I can't find him. Okay, I'll find it and I'll share it with you guys. Because the way that he does it, it's fairly cool. He basically forces the hardware to glitch. And he basically, he heats up specific areas of a chip, which cause it to glitch in a specific way that gives up more code than it should, and it gives up slices of the code that he needs. He glitches it multiple times until he has the entire code base, not entire code base, but the code portion that he needs for the seed phrase, and then he reverse engineers yeah, it is super complicated, and he reverse engineers that component. He gets a seed phrase, and then he dumps the seed phrase into a new hardware wallet, and he's essentially hacked a hardware wallet. He does it with Trezors, and I'm not sure which other devices he did. There was some sort of fancy YouTube thing where it was like, what, 76 million, 76, 1, 2, 3, 1, 2, 2. Yeah, let's see if that pulls out something. That. 75 million bulk hack here. And so I'm going to copy this link, and you guys are more than welcome to watch it. It is over there. I think it's the first video in this. So I don't know if this is the first one or the second one. This is the first one. So in the first 5 minutes, he basically shows you how he does it. The rest of it is him just like trying to unlock $76 million. Yeah, it's a rather cool challenge. The guy is doing it ethically. He's not actually stealing from anyone. But yeah, he's actually trying to recover people's seed. He's trying to recover wallets where people have lost their seed phrases. So he's doing a good thing. He's not, and he doesn't reveal enough about how he does it to actually make it a prime thing where he's causing a problem. But yeah, I'd love to get some questions from you guys. Are you curious about anything? Did you understand everything? And yeah. Cool, guys. It was lovely chatting with all of you tonight. I look forward to seeing you next week. We'll be here on Tuesday. I would like to give you guys some homework. So essentially, do go through everything we have here. Also, the videos are on YouTube, and the slide decks are available for you as well. Is everyone in the YouTube channel? Not the YouTube channel, the WhatsApp channel. Is there anyone? Let me just share the WhatsApp link in case someone doesn't have it. 1 second, guys. Nope. And how do you copy this link? Invite via link. Copy link. So if you guys don't have it, you can find that over there, and then you can join the group and everything else will be available for you. Are you sure no one has any questions, guys? Okay, cool. Well, I'm gonna kill the session now. I hope you guys have an awesome night. Cool, guys. Like, that was fun now that we're no longer recording. But thank you very much, guys. I really appreciate it. Thank you, Precious. Thank you, Sviso. Thanks everyone for being involved and joining in. Cool, and thank you, Vikas. I appreciate your questions.
Did you actually record? Is the question.
Yeah, I did record. Oh, it's still recording.
Okay.
I was supposed to hit stop recording.